Hey guys, Jeff here. Today we're talking about the differences between the analog world and the digital world. Welcome to the Practical Nerd. The main characteristic of analog information is its ability to store information with infinite precision. Digital information is limited and deals with information that has finite precision. Let's explore these two with a couple of real-world examples. We're going to use a vinyl record to represent our analog data and CDs to represent our digital data. Although both items are used to store and play music, the technology behind them is very different. Let's take a closer look at a vinyl record. The information on a vinyl record is read via a stylus and gets amplified to produce sound. But what exactly does the stylus see? On the record, the sound waves are directly etched onto the vinyl. As the stylus moves across the surface, it continuously moves up and down. This continuous movement is what defines analog information. The key takeaway here is that analog information is continuously variable physical quantity. In this example, we use sound waves, but this applies to other physical quantities such as voltage, temperature, pressure, position. Now, let's zoom into the CD and see how digital data is stored. The CDs store their information in a series of ones and zeros, which is read with a CD player via a laser and a sensor. Looking at CD RW in particular, one of the four layers contain the data. We can change the data by raising temperature of specific patches of the metal alloy. We can get patches of crystalline material, which allow a laser to pass through, or amorphous material, which disperses the laser. If it gets reflected, the sensor reads it as a logical 1. If not, it reads it as a logical 0. These series of ones and zeros are grouped together into sets, which represent the amplitude of the sound wave at a given time. The standard audio CD format is recorded with 16 bits and sampled at a frequency of 44.1 kHz. This means that the audio CD format uses 16 ones or zeros to store a single point in the sound wave and records 44,100 points in 1 second. Notice how there is a slight misalignment between the analog recording and the digital recording. This is due to the limited 16-bit resolution of the digital data. We are forced to truncate part of the data due to the infinite precision of analog data. Also notice how the value increases incrementally while the analog data is smooth. This is due to the limits on the sample rate. But why do these limitations exist? Let's play a quick game to illustrate the point. I want you to write down the numbers on the screen, analogous to how a computer would try to store numbers in their memory. The first round was pretty easy, but let's try going a little bit faster. The second round was a little bit harder, but let's make it even harder by adding a few more digits. So, how did you do? Were you able to get all of them? In a computer's case, it has to deal with an infinite number of digits, and it has to record them while they are constantly changing, faster than our human eye can see. The number of digits is analogous to the 16-bit resolution, whereas the rate you are able to write down numbers is analogous to the sample rate. This limited resolution and non-continuous behavior is what defines digital information. Now that we understand how both analog and digital information work, it seems like analog is a way to go. But there's a catch. Let's imagine that there's a bit of background noise in the room that you're recording in. All that noise gets transferred directly into the sound waves. If we want to edit that noise out, it would require a lot of effort. This is an example of one of the weaknesses of analog data. It is more susceptible to noise. In digital audio, we can reduce the noise by modifying the ones and zeros. This is accomplished by using audio software. Now let's say we want to record our video on a record. How would you accomplish that? Is that even possible? It's clear that we would want to use some other physical hardware to do this. This is another example of one of the weaknesses of analog information. The hardware used to store and read analog information is application specific, meaning if you want to record, store, and read analog data, you would need a different set of machines for each type of data. This is one of the major advantages of a digital system. By simply modifying how the computer interprets the ones and zeros on the disk via software, we can store any kind of information, be it a song, a video, a picture, a graph. The possibilities are endless. This versatility is what makes digital information as widespread as it is today. To summarize, analog information is a continuously variable physical quantity. Digital information, on the other hand, is non-continuous. Analog information has infinite resolution, whereas digital information is versatile and robust against noise. Analog information requires specialized hardware for each application. It is also susceptible to noise. Digital information is limited by resolution and sampling rate.